In the fossil record, it is evident that different groups of plants have evolved the ability to produce trees with woody material, and some even with the ability to grow wider through secondary growth through different mechanisms. And there are woody tall plants today, such as bamboo and Joshua trees and others, which develop their treeness through different mechanisms than the majority of trees alive today. So the ability to develop trees which grow tall and then even wider each year has occurred independently multiple times. That being said, most trees alive today have derived their treeness from one common ancestor in the history of seed plants. And so early in the history of seed plants, trees adapted to become tall with woody tissues and also the ability to grow wider through secondary growth. So what we see in the dicot trees alive today, where there is a ring of vascular cambium, which allows them to every year add new layers of xylem and phloem. This is exactly what we observe in pine trees as well, because both the dicot trees and pine trees have retained this mechanism from their single origin in seed plants. And so in these images, you can see that in a first year pine stem, one layer of primary xylem, but then in following years, by the second year in these microscope slides, that additional layers of secondary xylem have been added because there is this ring of meristematic tissue, stem cells which have not yet decided who they would like to be when they grow up, that can differentiate to become both xylem and phloem. This meristematic tissue completely encircles the stem and so therefore allows additional layers of vascular tissue to be added each year.